describes the perpendicular cross sections of a soup can. So the soup cans look like this. When you slice them that way, the other way to think of it is like piece of fruit, like a cucumber or banana. If you cut the cucumber or banana, you know what kind of shape that is.
Yeah.
It's the same as the top and the bottom also.
So in this case, it'd be a circle.
That is correct. Very good.
Okay. All right. Number 2 is done. We probably should check it. Pop that in the chat. All right, it's in the chat.
Okay. Take a look here. Right. Yeah, I mean, so the hardest part about all this is like if you had this in front of you and you tried slicing it, you should you should be able to figure out what it looks like. So Mateo is drawn a line to represent the parallel cross section of the triangular prism. Is he correct? So the thing is, the cross sections, they have to be parallel to the base. Parallel to the base. Okay, so what do you have any idea what I mean by that?
Yeah.
Yeah, so in this case, parallel to the base, like the soup can, when you cut it, parallel to the top and the bottom. If it's a triangular prism, when you cut it, it better be a triangle when you cut it. So the line should be parallel to the triangular faces like you have there. That's correct.
Got it. All right. Let me put the next one here. So here's number. All right, so the next question's in the chat.
Okay, let's take a look here. Cylindrical containers. This is like a tennis tube with tennis balls and so. Oh, that's what it says. Cylindrical tank container contains 3 tennis balls or 5.4 inches in diameter, lying on its side and pass through an X-ray scanner. Scans the top only. What outline will appear on the X-ray screen? Interestingly, when it says top, does it mean, is this the top or is over here the top?
I think it means the right side, the 5.4 inches, that's the diameter.
Okay.
That is the
Yeah,
top, and then 16.2 is like the height, I
got it.
guess. If it were to be like right side up.
Well,
Yes, that's
that's
it.
why we're trying to figure this out here. So if you look at the balls from the side, they might touch and look like that, but that's certainly not a rectangle. If you look at just from the top, it's like the can, it's a circle. So it's a circle with a diameter of 5.4 inches.
Got it.
Guess. I mean, yeah.
Yeah, because then it would have to be the
The
diameter of.
rectangle, the problem with the rectangles is it's not exact because there's these balls that are like this.
Got it. I thought it like an X-ray screen would be like from like the front of it, which I guess in
Right.
this case would
Right.
be
It's
the.
front though isn't quite a rectangle because it's really these three circles.
That's what they're trying to get. All right. So here, let me put the next one in the chat. All right, the next question's in the chat.
Which of the following two-dimensional shapes can be rotated to create a sphere? So that what they mean by that is is if you take a circle and you kind of like flip it 100, 360 degrees, you know, that thing becomes the sphere like that. Does that make
Got
sense?
it. Yeah.
Okay.
So it, yeah, so it's rotated to create a sphere. So then it would be the circle.
It would be the circle, yeah. Hang on just a second. All right, Karthik, thank you. So got that question here up in the chat. So you'll see this again in calculus 2. It says a triangle and a horizontal line. So the triangles revolved around the horizontal line. What is the resulting object? So at a minimum, what you can do here is actually like frame it on the other side. And then that might give you some idea of what it is.
Got it.
So in this case, it's the cone. Now it's kind of an interesting exercise to look at what are all of them. So if it's a square or a rectangle, this becomes a cylinder. The ring here is is if it's offset. So let's say it's something like this and you're rotating it like that, that becomes the ring or the washer. And then this one down here is the frustrum. It's kind of a trapezoid that there. So maybe that helps. I don't know. Depends how visual you are.
Got it. Okay.
Gonna drop that next one in the chat. We'll
It's in the chat now.
right. Let's see here. So that in. Around which line would the following cross section need to be revolved to create a sphere? Okay, so you've got some of them. So the line x equals 1 is your choice. That's a pretty good one. Yeah, so it's got to rotate over itself. So that is correct. If you rotate it over this line, it becomes like a donut, I guess is probably the best analogy I can make with very little, an infinitely small like center. I don't know if that makes sense. It's like a ring tube. I mean, it's something like that, except it's really tight. Like it's like that. I guess that would be the right picture, something like that.
Got it. Okay. Um, the next question is 2 inches. The first one's the question. The second one, just all the possible answers.
Yeah.
Yeah,
Right.
too small for
So
the same.
Jeanette needs to break down the food container shown below for recycling purposes. Which of the following resulting net of the food container? So I think what they're trying to show here is it's the, well, so a cylinder, let me do a cylinder because I don't, this isn't quite a cylinder. Cylinder is 2 circles. That's the net. The net just means the like flat shape.
Yeah, yeah.
Okay. Now this one kind of tapers in a little bit, but it still has a top and a bottom. So I'm leaning towards, but the thing, like,
But yeah,
I,
because it says a food container, but I'm not sure. It would probably have. I think if they want us to kind of assume there would be two, like the top and the bottom, but that's why I put the third option because it's the one that has like the I guess the bottom of it. But yeah, it's either the first one or the third one.
so I mean, yeah, I mean, if it's just a top and like, but the thing is, it kind of tapers in, but it's not a cone. So the wedge here is if it's a cone.
Yeah, because if you were to roll that, it would if you were to roll it in like a 3D figure, it would be a
Yeah.
cone. The
Yes.
circle is the bottom.
But I guess I'm not much help here. I mean, it's a top, it's a bottom. I mean, it
So the
tapers in.
closest thing would be the first one then, because it
Yeah.
has the top that I guess that's supposed to resemble the lid on the top.
Yeah. I mean, I'm not convinced, but maybe, maybe. I mean,
Alright. Alright, so here's the next one in the chat.
Okay. All right, a pencil. Pencil consists of a cone stacked on top of a cylinder. So here's the cylinder, the can, and then there's a cone right on top of it. Okay, does that make sense?
Yeah.
The pencil consists of a cone. The diameter of the cylindrical base of the pencil is 10 millimeters, and the height of the cylinder is 70. So 70, and then this is 10 across here, while the height of the cone is 12. Calculate the surface area of the pencil. Okay, so this is new. We haven't done surface area yet. So the surface area is the outside edge. It's like what you would paint if you had to paint this thing, right? So if you were to paint this thing, you would need the surface area of the cone, and there's a formula for that. It's on that reference sheet I sent you the other day. Let me just drop in the chat again in case you don't have it. But it really is good. Like these reference sheets, it used to be you'd print them out and you'd have them like in books and right there with your studying. Now with the internet, you just do that. But the surface area is kind of a complicated formula. It's of a cone. Surface area of a cone is pi r squared plus pi r s. And you're like, what is this s? Well, this s is right there. It's called the slant height. Okay. And so I think that's a little bit odd. But that is what it is. It is the slant height. So
Got it.
so in this case, the pi r squared is the bottom, but we don't have the bottom because it's already attached to here.
Got it. Here. Um, All right, I got 15 for the surface area, which for that would be pi rs. I calculated that and I got 15.7.
So Karthick, I apologize here. I got to go deal with something, and I'm just not going to be able to finish our lesson. I'm going to credit you a lesson. I've just been really out of it. I'll get that made up to you tomorrow, but I really do need to run here, and I
Hey,
do
no problem,
apologize.
no problem.
All right, thank
Yeah,
you.
this
Bye.
is